in a little bit. So let me just send a reminder to everybody and then we'll start. Just 1 second. Let me just mention this. Alright. So let me just alright. So yeah, somebody has raised hand. Even Gitesh is not here, but that's okay. I'm hoping that puts extra work on you guys. Whoever is missing the class, whoever is late for the class, will have to watch the video extra by spending more time. Alright, somebody raised the hand. No? Alright, so tell me, what did we learn yesterday? Yeah.
We learned about more about the
Linear equations. We learned about linear equations. Yep, yeah, Dikshita.
Linear equations.
Yeah. Alright. So linear equations, as we discussed about, linear equation is nothing but an equation with maximum power as 1. Maximum power as in maximum power to the variable. If I am talking about this as an equation, 5x plus 6y minus 17 equals 0. Here this is a linear equation because it's not, okay, I will let you guys speak for that, okay? But don't stop interrupting me in between, okay? That's not good. Now, if I'm talking about this as an equation, I'm calling it linear equation because the power to the variable, the maximum power to the variable is 1. And that forms a straight line. That helps us draw a straight line. That's why it is called a linear equation. Any confusion so far? No? Anybody? Karthike, Sam? I'm asking Karthike, Sam, because they are new in the class today. That's what I'm asking. Okay? Alright. Yeah. Aryan, are you fine?
Yeah.
Okay. Now, when I said that this is a linear equation, meaning it draws a line, I did not prove that. So let's use that information, whatever I said, let's use that to figure out why it is a linear equation and why we are saying that it's a linear equation. Because literal meaning of linear equation is it's an equation that draws a straight line. Let's see if any equation like this helps us draw a straight line or not. And today we will talk about the coordinate planes, and we use the coordinate planes for drawing the straight line using the linear equation. Let's say this is my linear equation. Okay? Why we are saying linear equation? Because the power maximum, this is equation because they are equal to sign, and the maximum power to the variable is 1. Maximum power is 1. Okay? So this is a linear equation. Conceptually, just because I am saying so. Now let's prove that. This is my coordinate plane. When I say coordinate plane, I am essentially saying we have two number lines. 0, 1, 2, 3, 4, 5, 6. Here if I go minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. So on and so forth. So these are two number lines just perpendicular to each other and meeting at 0, the center. Okay? So here 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. I'll just draw up to 5 so that we can see. This is how a graph looks like. Okay? So let's graph paper that I was talking about. This is how it will look like. I'm just drawing it for you guys to be able to relate. This one will cross through 1, 2, 3, 4, 5, 6. Then this one. I know it looks clumsy, but it will help us draw something, okay? Now, what we are trying to do is, we have a linear equation like x plus 2y equal to 15. I am saying this is a linear equation. If you have to draw a line using that on a graph paper, how will you do it? You will find out 2 points and then join them. That will help you draw a line. 2 or 3 points maybe. Let's look at 1 point. When value of x is 0, what is the value of y here? In this equation, x plus 2y equal to 15. When I say x is 0, how much is value of y? Okay? Yep. Okay. No. Okay. I got 2 answers. Okay. Let's see what Aryan has to say. Yeah, Aryan.
The value of y is 7.5 or 15 over 2.
Okay. So that's the answer. Okay. So you can see when you put x equals 0, any point, what you're saying is when x is 0, what is the corresponding value of y as per the linear equation? That's what gives me x and y coordinate for that particular point. So when x is 0, value of y will be, this is 0, so 15 by 2. So 7.5. This is 1 point, okay? Now look at where x is 0, y is 7.5. Where x will be 0, it will be somewhere on this line. Every point on y-axis will have x value as 0. Yeah? Any point you pick up on the y-axis, this is my y-axis, okay? And this is my x-axis. Any point you pick up on y-axis, the value of x will be 0. So if I say point x equals to 0 and y equals to 7.5, it will be somewhere here. Since y is 7.5, it will be somewhere 6, 7, 7.5. So we are talking about a point here. If you look at this point coordinates, the value of x is 0 because from the y-axis, and the value of y is 7.5. We got 1 point now. Now look at second point. We made x as 0. Now let's take y as 0. If we make y as 0, then x will be equal to 15. Yep. Yep. Aryan, is that what you're saying? When x, yeah. So when y is 0, x is 15. So when y is 0, x is 15. It will be somewhere on my wall actually, right? So let me do this way. I'll say this is 5, 10 and this is 15. Okay? I'm just trying to, and then I said minus 5, minus 10, minus 15, minus 20, 25, 30. I just change the scale so that I can draw it in the same scale. Now, when y is 0, x is 15. So on the x-axis again, every point and any point that you pick up on the x-axis, the value of y will be 0. So we are saying when y is 0, x is 15. It is coming to this. If you join these 2 points, this is your line that is drawn by this linear equation. Yeah?
So linear equations can be put into coordinate planes.
Yeah?
Wait, so then are those like the graph plots? Like or different versions?
Stop it there. Stop it there. Right now, let's learn the linear equation. When we are talking about linear equation, it draws a straight line. And straight line, when you draw, be it a line, be it a circle, be it a triangle, be it a rectangle, you are drawing a 2-dimensional plane. The other 2 dimensions, x and y axis, that's what. Okay? Now, yes, Siddharth, you had a question.
Sir, I don't understand a little bit about the linear equation.
Okay. You tell me what did you understand so far, so that I would know from where to start.
Well, I understand about the x equals 0, the y thingy, but I don't understand like the freedom.
Okay, so now let's not try solving it, okay? Let's try understanding it first. First of all, when we say linear equation, simple thing is, in English if you say, an equation which helps you draw a simple line, straight line. That's just the literal meaning. You're just assuming that whatever I'm saying is right, okay? You're not believing me yet. So linear equation is an equation that helps you draw a line. Now, how do you draw a line? What do you need for drawing a line? You need at least 2 points, which you will connect and then extend, right? if you have to draw a line or line segment, what is the minimum that you need? If you just have a point, you can have n number of lines that can cross to that point, right? If you have to form up a line, a right line that you want to draw, you need 2 points. If you have 2 points, then this line cannot change. It will have only one direction. It will be here to here. If you have these 2 points, you cannot have a line like this. Yeah? Because this line has to cross or in simple terms, you need 2 points for drawing a line. Yeah? Are you with me so far? Okay. Now, here we had an equation. We had an equation which were claiming that this is linear equation. Okay? Hi, Sagnika. Okay. So, when we say we had a line which we were claiming as a linear equation, we are trying. What that means is, any and every point on this line will follow this condition. This is a contract. You are saying that for any value of x and y, the sum of this will be 15. Now you can increase x, which will decrease y, but total sum will be 15. You can decrease x, but increase y, but the total sum will be 15. This is the contract. When you look at the equation, that is nothing but a contract which says, if you meet this condition, or any point on this line will meet this condition. Where if you pick up this point, here x and y, value of x and y together. Let's say x will be what? X will be probably minus 22 and y will be minus 3. Sorry, x is 22, not minus 22. This is positive direction. And y is minus 3. So here 3 or maybe 3.5, whatever. So 22 plus 2y, y is minus 3 or minus 3.5. See, this gives you 22 plus 2 into minus 3.5, it makes it minus 7. See? So when the value of x increased from 0 to 22, y became negative. If I go up here, if I go to this point, meaning value of x is increasing, decreasing. Value of x is what? Maybe 5, maybe 4. Here, see the value of y. Y is very high. So, this linear equation tells you that this is a contract between x and y. So that the combination of value of x and y gives you a total of this. Am I making sense so far?
Easy.
No comment like that. I'm hearing from people. You can claim it to be easy, and that will reflect when you do sums. That's it.
So anything on the line
Will, yes, any point on the line, if you apply this formula, take the value of x and take the value of y, substitute it here, then it will give you 15. Siddharth, is that making sense so far? Yeah. Okay. Yeah. Yeah, Dikshita.
Is this a kind of like a one-step equation?
It is a simple equation. It's a linear equation. Simple one equation, okay? Where it's giving you an equation where there could be multiple values of x and y. And the values of x and y will be such that every point you pick up, that corresponding value of x and y together will give you 15. Following this rule. That's what the equation is. So when you plot an equation on a graph, when it beats a line, beat a curve, any and every point on whatever you have drawn using that equation will follow that contract. Let's say if I say x square plus 2y equal to 16. This is a quadratic equation. When you plot this on a graph paper, it will make a parabola. Okay? Don't worry about parabola. I mean, you still have some time. But what I'm saying is, now every point, if I pick this point and find out the value of x and y and substitute in this equation, it will give me a 16. That is what it means. Meaning, when you have used an equation to draw a shape on the graph paper, each and every point on that shape will satisfy that condition. Does it make sense?
Yes, sir.
Yep. Aryan, Namuga, Sagnika, everyone, Myra, everybody okay? I might miss some names. That doesn't mean I'm going to miss any of you, okay? I'll keep on reminding, keep on checking. Here in the class also, everybody okay? So when you have an equation and when you use that equation for drawing a graph or a line or a curve, whatever it is, what that drawing means is every point on that will satisfy that condition. So that is why we chose 2 points for drawing this one. We picked where s is 0, meaning where it is meeting the y-axis, and we picked where y is 0, meaning where it is meeting the s-axis. And then we use those 2 points to draw this line. And when you have drawn this line, you can just pick up any point here. And you will find that, take the value of x and y for that point, x and y coordinate, and substitute here, you will get a 15. Does that make sense? Okay. Now, what is the interpretation from what we have seen here? If you are using a linear equation to draw a line. Now you guys can believe me. Okay, we have just drawn a line. You could have gone one more step. You could have said, okay, when x equals to 1, what is the value of y? Put it here. When x is 1, y is 7. Now when x is 1, y is 7. When x is 1, y is 7. Probably here, somewhere here. Just below 7.5. And then you will see that that line also falls on, that point also falls on that line.
It will be closer to like the y amount. Meaning that they didn't like, it was like more further. If it was slow. So it's different formulas and like a different angle of lines.
Yes, yeah. So if you use different formulas, you will have different magical rotation of lines actually, depending on what formula you are using. If I am using, and we'll get to learn more about it. So then when you guys go to the next level of understanding or learning things, that is when you will talk about different formats of line, where we will talk about slope-intercept form, the standard form and whatnot. Okay? So right now don't overburden yourself by thinking too much about it. But yes, the point here that I am trying to make is, if you have a linear equation and you pick up any combination of x and y, pick up any number of x, any value of x. Okay, let's say 5x plus or minus 2y equal to 17. Just by looking at this equation, you can make out that this is a linear equation, because the maximum power on this one is 1. On the variable is 1. So this is a linear equation that is given. That's like a universal truth. Nobody can change it. Okay. Now, when you try plotting that, what will you do? This is your graph paper, let's say. Okay. Now, what will you do? Let's take x. When x is 0, what is the value of y? When I say x is 0, what is the value of y? So when x is 0, minus 2y equal to 17. Y is minus 8.5. So when x is 0, y is 8.5. Let's say this is 3, 6, 9. So this is somewhere here. Yep. Yeah, Dikshita.
So this linear equation only contains like one variable or like
It will contain 2 variables, x and y, because that is how you will be able to use that for drawing it in a coordinate plane, where you have x-axis and the y-axis both.
oh, okay, so
Yeah. So this is your x-axis, this is your y-axis. Now here in this case, what I did, I picked x is 0. Now and then we got value of y. So I got 1 point. Now let's pick second point where y is 0. What happens when y is 0? 5x equals 17. So x equals 17 by 5. 3.4. So when y is 0, x is 3.5. So let's say this is 3, this is 6, this is 9. So this is 3.5, somewhere here. We got 2 points. Now look at this line. this line is little more vertical. Earlier it was slanted. So depending on how your equation is formed, your line will rotate. Right now you are seeing it like this. It might rotate depending on how your equation is framed. So your equation determines how your line would be, or what kind of line it will draw. Yeah. So one assignment to you guys, okay? Even if I forget, 6x minus 12y plus 13 equal to 0. This is your equation, okay? Use this equation to draw line at home, not right now, at home using a graph paper. Take a printout of a graph paper and use this equation for different combination of x and y, try plotting it, okay? And then that will tell me whether whatever I have explained, are you able to follow it or not, okay? You will draw the line and show me a picture of that in WhatsApp, yeah, for everybody. It's there in the video also, I have written it here also. 6x minus 12y equal to plus 13 equals 0. This is the equation, okay? Now it's up to you whether you want to find it from the video or you want to note it down now. Yeah, Dikshita, you're asking something.
So like you point like the points, like you plot the points, like now you have like 5x, so you point like the 5x down and the 17 out.
No, so see, let's take one step back. If I have to draw a line or line segment, what do I need? I need 2 points. Yeah? And those 2 points, if I am claiming that they are lying on this line, then they will also satisfy this condition. Yeah? So I am saying my 2 points are such that one is beating the y-axis where the x value is 0, and second is beating the x-axis where the y value is 0. That is how I am finding 2 points. Now?
Wait.
Okay, let me repeat. If I have an equation, and trust me, this is the easiest part and this is the most complicated part. It might take a couple of attempts to digest this, but once you understand it, this will be easy. Okay? Now, everybody here with me, okay? If I have an equation like this or this, what that means is, if I pick any value of x, there will be a corresponding value of y, which will give me together the value of this. This is like a contract, right? When you move into a house, when you buy a house, when you go into an apartment, any which way, we sign a contract, right? Which says that these are the rules to follow, these are the conditions to abide by, these are the disciplines to be enforced. Yes? That's what a contract is. Even when you are in school, when you guys go to school, there are certain rules to be followed, right? If you look at this equation, this is nothing but a rule which says that your combination of x and y will be such that together the value will give me 17. If you look at this equation, what this contract says is the value of x and y, or the combination of x and y will be such that together the value of this will be equal to 0. This is like a contract. You are saying that as per this contract, value of x and y are to be chosen such that my total value of this part gives me a 0. Or any equation, be it a linear equation, be it a quadratic equation, be it any binomial, trinomial equation, right? Any equation is nothing but a contract. That just tells you that this is my condition. You choose the value of x and y so that you get this value. And in this case, choose the value of x and y. Every combination of x and y which gives me this value is sticking to this contract. And that is why they are falling on this line. Any point falling on this line is sticking to this contract. Meaning, you pick up a value of x and y, you pick up a value of x, there will be a corresponding of value of y such that you will get this value. So that is what happened. We said, okay, fine. I want to choose value of x as 0. Tell me what is the value of y. We chose the value of x as 0. It gave me a value of y minus 8.5. So I made a mistake. It would have been when I chose the value of x as 0, my value of y was minus 17 by 2, that is minus 8.5. Minus 8.5. So it would have been here. So I said, okay, fine. When my value of x is 0, then value of y is minus 8.5. That satisfies the condition. So this point is on that line which will be drawn by this linear equation. Now I am saying second point. Yes, Amoga, I will come to you with that. Second point, let's say if my value of y is 0, what is the corresponding value of x? When the value of x, y is 0, value of x is 3.4. It is here. So this is my line. See, I had made a mistake in selecting the first point. That is why the line was looking like this. But actually the line is like this. Yeah, Moga, you have a question. Unmute yourself and tell me. I cannot hear you. You have to unmute yourself. Some problem with the network, but maybe you can disconnect and join back. Can you hear me? Can you hear me? Okay, but I cannot hear you. I think everybody else cannot hear. Everybody else cannot hear Amoga, right? No. So Amoga, you can probably disconnect and join back again. So yeah. What is that? Did you not bring your water yesterday? As I said yesterday? No. So you have to remember that. If I go for bringing water, 10 minutes of the class I'll be losing. Okay? Make sure you use your restroom before coming, and make sure you bring your water, please. Okay. Yeah, Dikshita, were you able to follow what I said? Yeah? So, again, any equation that we talk about, that equation says that this line or a curve, whatever it is a combination of x and y such that it follows this concat. Yes, Amoga, you want to say something now? I cannot hear you still. She disconnected, join back again. I cannot hear you better. Okay. Anybody in the classroom who has any doubt about this so far? Anybody? Myra, Sagnika, Siddharth, Aryan, Vivan. Anybody? No? Okay. Yeah, Amoga, can you try saying something now? Okay. Yeah. Kartikeya and Bala, Sam also fine?
Yes.
Okay. Yes. Good. Yeah, Moga, you want to say something? I'm sorry, but I cannot hear you. Not at all. And trust me, I'm not saying anything wrong. Nobody can hear you actually. Right? Dikshita, you cannot hear her, right? No. Okay. So everybody is clear about what we have learned so far. Again, one last time. If you have any equation, be it a linear equation, be it a quadratic equation, be it a polynomial, whatever it is, an equation helps you find out different combinations. Let's say, no excitement. Just by seeing the equation, if you start jumping, I will write 100 equations here. You will jump a lot. Okay, coming back to the point. What I'm saying is, if I have any equation, an equation gives you all possibilities of x and y, in this case, which will satisfy this condition. All possibilities of x and y, which will satisfy this condition. And if you pick some of those possibilities, let's say first possibility is x equal to 1, y equal to 3. I'm just making it up, okay, not solve it. If this satisfies this condition, that becomes my 1 point. Okay, x is 1, y is 3. So here, this is my first point. Let's say second, based on this equation, my second point is x is 2. Let's say y equals minus 1.5. So when x is 2, y is minus 1.5. This becomes my second point. Or here, sorry. Let's say when x equals 0, y is 6. I'm just making it up, okay? I'm not calculating right now. So when x is 0, y is 6. So here. So this is making a curve. Now what that means is, any and every point on the curve, let's say we just pick 3 points. If you pick this point, this has also x and y value. If you pick that x and y value and plug in here, it will satisfy that condition. So any point and every point on a line will satisfy that condition. That's a contract. Like in a school, put your hands down. If in a school there are 50 students in a class, if there is a rule given by the teacher, every student in the class follows that rule. That is what is an equation. This equation gives you a condition. Now, if you look at a simplified statement from that, this is not giving you a solution. This gives you possibilities. This gives you what are the possible values of x and y. This doesn't give you one pinpointed answer. Amoga, you want to try saying something again one more time? You have raised your hand, but I cannot hear you. Bad luck, beta. Very bad. I cannot hear you. Sorry for that. Maybe you can type in a chat window if you have a question. Can you typing in the chat window? Yeah, you have a question now. Arab, you have raised your hand. No. You raised.
So when you're in the line, when it goes like the third quadrant, then
Doesn't happen. Any quadrant you go to, you have x and y value. Pick up any point from that, it goes to third quadrant, fourth quadrant or 20th quadrant. Wherever it goes, you are picking a point and every point will have x and y coordinate. Pick up the value of x and y, substitute in the equation, this will satisfy. That's the deal. But it has to be on that curve or on the line. Okay? Yep. What is that? Turn it down. But be careful. Okay. Anybody in the class have any doubt? No? Now, the simple interpretation from what we have learned so far is that when we have an equation, linear equation or quadratic equation, whatever equation it is, it gives us different possible combination of x and y. That is what, if I am talking about a linear equation, let's look at this. If I am talking about a linear equation, let's say x plus 2y equal to 3. I am just making it up, okay? I am not doing any calculation, I am just showing you guys the concept. If I have this a linear equation and if this draws a line like this, okay? Doesn't matter, I don't care about the answer. I am saying the concept, focus on the concept, that's why I will keep on guiding you guys back to the concept. I am just saying that this is my equation that draws this line. This might be a round line, this might be something else. When you draw it accurately, you will get the line. What I am saying is, this line when you draw, every point on the line, any and every point that you pick up on the line will satisfy this condition. You pick up the value of x and y on these points, any point on the line, and substitute here, you will get this value, if this is a correct line. That is what it means. Now, so here you are seeing so many values of x and y. Now I am showing you guys something magical which you would have probably not thought about. Now let's say this is one equation. This is second equation. Okay? When I look at just this equation, it will also draw some line.
instead you can see the community variable is y. So it could be
So this is where the problem is. You're not trying to learn, you're trying to show the expertise.
The third one intersects with the second one.
So wait, what I'm saying is, I'm making a very simple statement here. I have one line, linear equation, that draws a line, okay? And I have a second linear equation that draws another line. Maybe this way, maybe this way. I have not done the exact calculation, but it draws a line. It's a linear equation. It meets somewhere, the other line. Wherever it meets, find out the x and y coordinate of that point. That is the solution for x and y. It's not similarity. So this is where it says that this line and this line meet some place. That is the intersecting point. That is where these two lines satisfy one condition. And that is the absolute answer that you get. Here, whatever value of x and y is, that is your solution. That's why I was saying that if you want to solve for two variables, you need two equations. And graphically, if you want to see it, they will cut somewhere. And wherever they cut, wherever they intersect, that is your solution point. Yes, Dikshita. You're talking on mute, better. You have to unmute yourself first.
I forgot the question.
Okay, so let me repeat it for you guys. Now, so far we have kind of struggled with one concept. Okay, if I have a linear equation, that draws a line. We have drawn a line. How do we draw a line? We pick a value of x, some value. We can put x equals to 0, 1, 2, 3, whatever we feel like. Something easy and simple. And find out the corresponding value of y. That gives me 1 point. Pick up another value of x, another simple value, be it 0, 1, 2, minus 1, whatever. Simple value. That gives you second point. You join them, that makes a line. So we learned with a linear equation, we can draw a line. And when you draw a line, what it means is, that is a contract which says each and every point on that line will satisfy this condition. But it doesn't give you a solution. It gives you all possible values of x and y. If you have only one equation, it gives you so many points, so many possible values of x and y, but no one solution. Now if I have second linear equation as well, I draw the line. Wherever it meets, that point's x and y coordinate gives me the solution for these two linear equations, which we can solve it manually by the way we tried solving yesterday before, or we can just draw two lines and wherever it intersects, that is my answer. Yes, Dikshita, you have a question still.
So can you use like a different variable instead of x and y?
So, when you say different ways, what do you mean?
Like instead of x and y, we could put a and b like that.
Okay. So okay. Here the deal is this. We are trying to solve it for x and y actually. That's unfortunate problem. We have, so see, look at this. Somebody says, x plus 3y equal to 8. Find out the value of x and y. You cannot solve it. As we heard, that this cannot give me exact solution. Because if I have two variables, I need two equations. Remember?
one variable is given out and
What is that?
and then one variable is given out and equals to 5, then you can come up with a problem.
But that you are just finding the possibilities. When you say x equals to 5, then you will find the corresponding value of y as 1. But then, is that the only solution? No. Because it's like a drop in the ocean. This is your line. I said, okay, solve this for this one. And you said, yeah, 5 and 1. This is one solution. This is a possible solution. Nobody is denying that. But is that the only solution? No. So that is why this linear equation is a contract which says you can have so many points satisfying this condition with x and y value. Okay? So yeah, Dikshita, to your point, a linear equation gives you a line which is made of so many points. Now, with one equation you cannot solve anything. You will say, okay, fine, I have two variables, I need two equations. So your teacher is a little generous, says, okay, fine, let me give you two equations. Now you have two equations, two variables, you can solve it. There is one way of solving it like the regular algebra way. Or second way is what we were seeing now. Where we were saying that, okay, if I have an equation like this, I can draw a line. If I have an equation like this may be probably another line. I'll draw the two lines, and wherever they meet, look at the x and y coordinate of that, and that is going to be my answer. This value of x and y coordinate will match with the answer if you solve it otherwise also. Okay? So these are two options you have. But if you tell me, can we solve it without x and y?
No.
Answer is no, because we actually try to solve for x and y. Yeah? Okay? Alright. So, anybody in the class who has any doubt or confusion about what we have learned so far? Yes, Dikshita.
Oh, so it's like, can we put like 3y minus 2x in reversal?
No. So what you will do is, you have two options. You will isolate the value of x in y terms. You will keep, let's say you pick this equation, x equals 8 minus 3y. You got the value of x in terms of y. You pick up that value of x, substitute here, and then you solve. That is one option. Second option is, here you can multiply this whole equation by 3 and then subtract this equation from that. So that 3x and 3x will get knocked off and you are only dealing with y. Ultimately you are trying to get to a situation where you have an equation with one variable. Whichever way you do it. Or third option is, blindly take a graph paper, draw these two lines and then see where they are meeting. And that is the answer. So there are two options now you have. Yeah? Siddharth, was it clear? Aryan? Thanu?
Yes.
Thanu, is it clear? Is this better than yesterday?
Yes.
Yeah? Thanu, you had some questions yesterday, right? Did it clarify today?
Yes.
Okay. All right. So, Amoga, I'm sorry, but I'm not able to even take any of your questions today. I cannot hear you. Thanu, you have raised your hand.
Can you show me one more example with the manual?
With a linear equation?
Yeah, one more example.
Okay. So, everybody, I need your attention for next 5 minutes and that will be the end of our class. Okay. So, let's look at, I have, let's say, a linear equation. Okay, you guys tell me what is the linear equation. Give me a simple one.
X plus y equals 15.
X plus y equals 15. Okay, that's...
And then 3x plus...
No, only one equation. Only one equation we are trying to use. So I'll come to that one when we need that. Okay, x plus y equal to 15. This is one equation, okay? This is a linear equation. Everybody agrees?
Yeah.
Because the maximum power to the variable is 1. So it's a linear equation. Now let's look at this. I'll say this is 3, 6, 9, 12, 15. And minus 3, minus 6, minus 9, minus 12, minus 15. 3, 6, 9, 12, 15, minus 3, minus 6, minus 9, okay, minus 12, whatever. Now, I have the equation x plus y equal to 15. This is my x-axis, this is my y-axis. Let's say when x is equals to 0, I'm trying to find out 2 points. See, I'm trying to do it in a very simple way. I'm just trying to find 2 points so that I can join them and that becomes my line. And those 2 points have to agree to this contract. Okay? So let's say when my value of x is 0. When value of x is 0, what is the value of y? 15. When x is 0, y is 15. So we are talking about this point. This is where x, value of x is 0 and y is equal to 50. Yeah? Now, second point, let's say when y is 0,
So that's going to be 15.
then x will be 50. This becomes my second point.
Now we have to run double connect.
Just join these 2 points.
So it'll be like,
Okay. Stop. It's not like, it's just a line. So, when you join the 2 points, you got a line. Simple, Thanu. Everybody? I had an equation like this. I picked up a value of x as 0 because that was my choice. I'm trying to find out what is the relationship between x and y to meet this condition. What if I pick x as 0? What if I pick y as 0? And then I'm trying to find out the corresponding value for the one. If my x is 0, then y has to be 15. Then only this is 15. When y is 0, x has to be 15. So that is how I got 2 points. I joined them. And so this was my x is 0. This is x is 15 and y is 0. These are the 2 points we have got. And we use them to draw a line. Now you pick any point on this line. Let's say we pick this point. Look at this point. Again, my drawing might not be great, but look at this. Here, what is the value of x? 6. What is the value of y? X is 6, y is 9. 6 plus 9, 15. Satisfying the condition?
yes.
Yeah? Did you see that? Now, let's pick up this point. See again. Not well aligned. If you use a graph paper, it will be more accurate. But see, 12 and 3. What is the value of x? Value of x is 12 and value of y is 3. Add them together. You got 15 again. Yeah? So, what is happening essentially is, you just use 2 points to join this line, but any point that you pick up on this line, that will satisfy this condition. Yeah? Making sense?
Yes.
Easy to understand?
Yes.
Okay.
Yes.
Everybody with me? I know tomorrow is Monday, but still.
No. Well, also my turn.
No, so I was not trying to tease you guys, but yeah, I know it's a Monday tomorrow, but we have few more hours left for the evening on a weekend. Enjoy that to the fullest, so that you go back to school with a lot more energy. But then, go back to see, when we are learning something on weekends, while you will have in the back of your mind, oh, school is starting tomorrow, but you should always think, okay, am I learning something today? See, I was saying that I use 2 points to draw the line. I have drawn the line, but then, see, each and every point that you pick up, that satisfies this condition. That is what the meaning is. So, any line, any curve that you draw using a equation, that will satisfy, every point on that line or curve will satisfy this condition. Okay? That's what it means. Now, you were saying second equation. What was the second equation? No. Okay. So, if you have another equation, let's say 2x minus 3y equal to 5. Again, you can do the same thing. Put x equal to 0 and find out what is the corresponding value of y. Find out 1 point. And again, put another value y is 0. Find out the corresponding value of x. So that this is another point. Join them. And you will see that this meets somewhere. Wherever it meets, find out the x and y value of that point. That will be your answer for solving this equation.
3 and 12.
Yeah. No, not no. I mean, don't jump. Because you have not solved this equation yet. We have not got it correctly also. It might be wrong. So, when you have two equations, you can solve it like the algebra way, like what we have learned before, or you can use the coordinate planes, draw the lines, see where they are intersecting. Wherever they are intersecting, that is the x and y coordinate of that point is your answer or solution based on this thing. Yeah? Everybody is tired. Except me. Yeah? Yeah. So, is that clear so far? Are you guys okay with what we have done so far?
Yes.
Okay. So let me ask everybody one by one, because I want to. No, no, I'm not asking questions. I'm confirming that whatever we have learned. So it's very important to know the question before try answering it. Okay? You guys are. I know your energy level is good, but channelize that energy to your benefit, not to get distracted. Okay.
You know my dad says about every day math.
Okay.
No, my boy.
Let me go one by one. So, okay, here goes my glasses. So, Aryan, no question with whatever we have learned so far? Clear?
Yes.
Did we learn something today?
Yes.
Okay. Same, Kartike and Sam, are you guys comfortable with what we have learned today?
Yes.
Was it easy to follow?
Kind of. Yeah.
Kind of. Okay. There could be some gaps because you guys are kind of trying to learn my way of teaching or trying to follow my speed. So once I upload the video of the class, if you have any doubt, right, whenever you get time, so from tomorrow, today till next Saturday, right, till we meet again, use this time to spend maybe for 10-15 minutes you can sit down and watch the video to see if there's anything that is confusing and how you can clarify them. Okay?
Okay.
Right. So I'm just wait. Don't interrupt me in between. All right. So Dikshita, any questions? Did we learn something? Did we learn something, Dikshita? Yeah.
Yes, sir.
Okay. Then let's look at who is next. Then Myra. Did we learn something, Myra?
Yes.
Okay. Then let's see. What is that? Okay. And here, is it Pranav, Pinapur Reddy Srinivas, or I don't know the name. I'm sorry.
Can you hear me?
Yes, I can. Oh, okay. So this is. Sorry, say that again.
I'm new.
You are new. What is your name, beta? Lakshita, yes. So that's what. So Lakshita, when you join next time, I would request you guys to join with your name so that it's easy for me, okay? Otherwise, I'll keep on forgetting your name and I'll keep on calling wrong names, yeah? Yeah. So Lakshita, did you learn something today? Was it a good learning experience or so-so?
It's good.
Good? Okay. And if any of you have any doubt, I would highly recommend you guys to spend some time, watch the video to revise and take notes. Because, Advik, can you sit down? Sit down. Okay. Then let Arav sit down. Then Siddharth. Siddharth Sagnika. Any questions?
Sir.
Yep.
I had a few. Yeah, I didn't understand your example, but you talked too fast, so yeah, I didn't.
Okay. So then I have an assignment for you. Just watch the video of the class. You can pause me in between. Whatever I'm doing, just try kind of repeating that in a piece of pen and paper, and let me know if that is not helping. But then, point taken, I will try practicing to speak little slowly, okay? Yeah, if that helps. All right. Sagnika, how about you?
I understand.
Okay. Then Tisha.
Yeah, I can understand everything.
Okay. But are you finding something that is interesting enough to follow?
No,
Kind of.
yeah, kind of.
Okay. So see, the thing is, some of the concepts you would know already, some of the which you will end up revising in the class. Some of the concepts will be very new that you'll end up learning. Okay. So it will be a mix of that. Not every day would be equally exciting because there are a lot of things that you guys have learned by yourself also, right? So which you would be knowing. So it will be a mixed bag. That's how it will be. But yeah, even if you know something and then we are learning in the class, it should give you an extra option to to use that as an alternate, but should not confuse you. If you know something and I'm teaching you something that is getting you confused, please let me know, because I want to make sure that I'm being mindful of your time and my time as well. Yeah? All right. Let's see who is next. Salmika, Siddharth, Isha. Then Venkat. I see somebody with name Venkat, but was that Vivan? Oh, okay. So Vivan, so you put your name, beta. You always log in with your name, so I got confused. Okay.
Sir, it's because I joined from like a different computer.
Okay. But when you join, it gives you an option to put your display name. Try putting your own name, because I know your name 100 times better than I would know daddy's name. Yeah. Okay.
Sir, it's my laptop, sir.
Okay. Oh, okay. All right. And who is BJT? Tanu. Okay. So Tanu, you have raised hand. So tell me, what was your question?
Can you also use negatives for like the question?
Yeah, you can use negative always. So if you see a line always goes from first quadrant to fourth quadrant or third quadrant, depending on how the line is constructed. So you can always choose. You can use 0, you can use 1, you can use negative, because ultimately the line says that this is a contract where you choose one value of x and you get a corresponding value of y, which gives you a total of what the contract says. So you can always choose. Yeah, answer is yes. Yeah.
Oh, sir.
All right. So thank you so much, everybody here in the classroom. Artik and Arav. Anything that was confusing? No. What is that?
Now I know an easier way to solve equations.
Okay. So you can probably check with your dad if you want to continue learning from dad alone or learn as a combination of the two. Okay.